Welcome to Study Loop.
Okay, you've got a positive charge here and a negative charge here, separated by a distance of 2.4 meters, and a negative charge separated from a point P with a charge located there of Q equals 2.7 microcoulombs. Okay, and the question then is, what is the force on your point charge P with charge Q, right? So this is just going to be using the equation F equals K times Q1 times Q2 over R squared, where R is the distance between the point charges, right? So this is what you use to calculate dipole moments or just general force constants anytime you have point charges that are separated by some distance, right? So given that, we'll just have to do this twice and add the results, and then we'll also have to figure out directionality of each of these forces, right? So there's going to be a force on P from the positive charge and a force on P from the negative charge, right? And then we'll have to figure out what their sum is, and to do that, we'll have to figure out what direction each one is pointing. Well, we can figure out the direction kind of right now, right? If there's a positive charge and P is positive, is it going to attract P or push on P? It's going to push on P, right? So we can say they've told us that to the right is the positive direction. So the force on P from the positive point charge will be a positive number. And because the negative charge will attract P, the force on P from the negative charge will be a negative number, right? And then we can just kind of ignore the signs of the actual charges. They simply tell us what, on the numbers, they're just telling us the sign of the charge, right? So really what we're going to end up with is force on P from the positive thing minus force on P from the negative thing. Okay. And then we'll just use this equation twice, right? So in terms of the positive, right, note that the distance R is actually 2.4 meters plus 1.2 meters, right? Because it's the distance to the negative and then the distance from the negative to P, right? So it's going to be K times 1.2 microcoulombs times 2.7 microcoulombs over 3.6 meters squared. Okay, that's the force from positive charge, and then we'll be subtracting the force from the negative charge because it's in the negative direction to the left, and that'll be 3.2 microcoulombs times 2.7 microcoulombs over, and the distance between them is simply 1.2 meters, as shown in the diagram, squared. And if we want, we can kind of simplify this and factor out the k's and just say this will be k times 1.2. If we want, we can convert the units here. This will be times 10 to the negative 6 times 2.7 regular coulombs, right? That's a microcoulomb. 2.7 times 10 to the negative 6 coulombs over 3.6 meters, all squared, minus 3.2 times 10 to the negative 6 coulombs times 2.7 times 10 to the negative 6 coulombs over the quantity 1.2 meters, all squared. Then what is K? Of course, K is Coulomb's constant, which is 8.99 times 10 to the ninth newtons times meters squared times divided by, Coulomb squared, which is good, right? Because these coulombs will cancel, the meters will cancel, and we'll just be left over with newtons. And we've converted everything from microcoulombs to simply coulombs, right? So our units should be good to go. We should be able to just plug all of this into a calculator along with K and see what our answer is. Now, when I plug this into my calculator, altogether I get 0.05619. Looks like we only have two sig figs. This is in newtons, which, if we want to reduce this to the correct number of significant figures, I guess would be 0.056 newtons, right? And I noticed that your number, your answer is in units of 10 to the negative 12th, right? Which makes me think you both forgot to use the equation for k, right? Remember, it's 10 to the ninth, right? And then the other factor would be, remember to square the values in the denominator, your distances, right? Both of those may affect the size of your answer, I guess I should say. Right, but you're off by many orders of magnitude here, which leads me to believe it has something to do with an error in exponents somewhere, right?